Assalamualaikum and hi everyone. Galvanic cell part 6. For the final part of the galvanic cell, you are going to learn how to use the standard reduction or electrode potential values to compare the relative strength of oxidizing or reducing agent and predict the spontaneity of a redox reaction.
Based on Table 1, the reducing agent is the species written at the right side of the half-cell equation. The oxidizing agent is the species written at the left side of the half-cell equation. The more negative the value of E0 reduction, the higher the tendency for the substance to undergo oxidation process. Hence, the stronger the reducing agent. The more positive the value of E0 reduction, the higher the tendency for the substance to undergo reduction process. Hence, the stronger the oxidizing agent. Let us consider the E0 reduction for zinc, copper, and She. Based on the standard reduction table, the half-cell equation for zinc, copper, and She is as follows. Based on the half-cell equations above, the reducing agent of these cells are zinc, hydrogen, and copper. Since the E0 reduction of zinc is more negative, zinc has higher tendency to undergo oxidation process. Hence, zinc is the strongest reducing agent among all. The strength of reducing agent decreases from zinc to copper. Based on the half-cell equations above, the oxidizing agent of these cells are zinc 2+, H+, and copper 2+. Since the value of E0 reduction of copper 2+ ion is more positive, copper 2+ ion has higher tendency to undergo reduction process. Hence, copper 2+ ion is the strongest oxidizing agent among all. The strength of oxidizing agent decreases from copper 2+ to zinc 2+. Let us consider the following example. Based on the half-cell equations above, the reducing agent of these cells are X, Y, and Z. Since the E0 reduction of Y is more negative, Y has higher tendency to undergo oxidation process. Hence, Y is the strongest reducing agent among all, followed by X and Z. The strength of reducing agent increases from Z to Y. Let us consider the following example. Since the oxidizing agent undergoes reduction, you have to look at the species at which the oxidation number decreases. In the equation number 1, since the oxidation number of Sn2+ ion decreases from positive 2 to 0, therefore Sn2+ ion is the oxidizing agent. In equation number 2, the oxidation number of chlorine decreases from 0 to -1. Therefore, chlorine is the oxidizing agent. In the equation 3, the oxidizing agent is silver, since the oxidation number of silver decreases from positive 1 to 0. The oxidizing agents are Sn2+, Cl2, and Ag+ ion. Since the value of E0 reduction of chlorine is more positive, chlorine has higher tendency to undergo reduction process. Hence, chlorine is the strongest oxidizing agent among all, followed by Ag+ and Sn2+. The strength of oxidizing agent decreases from chlorine to Sn2+. Spontaneous reaction occurs as a result of different ability of metals to give up their electrons to flow through the circuit. If E0 cell is greater than 0, the reaction is spontaneous. If E0 cell is less than 0, the reaction is non-spontaneous. If E0 cell is equals to 0, the reaction is at equilibrium. Let us consider the following example. From the overall cell equation given, identify oxidation and reduction equation based on the changes of oxidation number. Then, calculate the standard cell potential. The E0 cell is positive, therefore, the reaction is spontaneous. Now, let us consider the following example. From the cell notation given, identify the anode and the cathode of the cell. Then, calculate the standard cell potential. Since the E0 cell is negative, the reaction is non-spontaneous.
Alright, so that's all for today. Hopefully we can see again in the next class. Bye and Assalamualaikum.